Hey everybody, my name is Scott from the Economics Tutoring Center, and today we're going to be talking about a z-score. So please keep in mind that teaching methods may vary. You're going to want to confirm all of my notation and language use with your professor. So the first question you might have is, what is a z-score and what does it tell you? And it tells you this statement here in quotations: how many standard deviations away from the mean is your data? And then we have some notation over here. Any individual value will just be x, a sample mean is x bar, population mean is mu, population standard deviation is sigma, standard error is sigma with this little x bar subscript, and the formula for that is sigma divided by square root of capital N. Capital N is your population size. So all of these values and notations come into play in these formulas. Note that we have two different formulas. They're actually very similar, but in one case you might need to calculate the z-score for an individual data point, and in that case you take your data point x, you subtract the population mean, and you divide by the population standard deviation. Again, that tells you how many standard deviations away from the mean is your data point x. If you want to calculate the z-score for a sample mean, you'll have a lot of data points, a lot of individual x values. You take their average, and that is x bar. Then you subtract the population mean, divide by the standard error. Remember, our standard error is standard deviation divided by square root of population size. So this formula here expands to this just by substituting this in for standard error. So now we'll go through a few examples of how to calculate a z-score. So now we're going to look at two examples of how to calculate a z-score, both for an individual value and a sample mean. So here's our question: what is the z-score of a value 17 given population mean 15 and population standard deviation 2.4? So this number 17 is an individual value, so our x is 17. Then it tells us our population mean is 15, so mu equals 15. And our population standard deviation is 2.4, and that's denoted by sigma. So then we'll go to our formula for z-score for an individual value. We take x minus the population mean divided by the population standard deviation. So now that's going to equal 17, which was our x value, minus mu was our population mean of 15, and then we divide by our population standard deviation, which was 2.4. So this will simplify out to 2, which is 17 minus 15, divided by 2.4, and you can calculate that in your calculator, and usually you write a z-score to 2 decimal places. So if you calculate that, it will give you a value of z equals 0.83, and remember to stop at 2 decimal places. So now we'll look at a new question, and we're told that a sample of 25 individuals has a mean of 70. What is the z-score of this sample mean given population mean 75, population standard deviation 10? So now we have a value 25, and that is our sample population size. We have a sample mean of 70, so now x bar is 70. We have a population mean of 75, so mu is 75, and a population standard deviation of 10, so sigma is 10. Now, if we go to our formula for z-score of a sample mean, we do x bar minus mu divided by the standard error, which, remember, simplifies out to sigma divided by square root of n. So now this equals our x bar, which was 70, and then we subtract mu, which was 75. We divide by our sigma, which was 10, and then divided by the square root of the population size, which was 25. So now this simplifies to 70 minus 75 is negative 5. And then we have 10 divided by the square root of 25, which is 5. So now we have negative 5 over 2, because 10 divided by 5 is 2. And this equals negative 2.50. So that's our z-score for this problem. Those are two examples of how to do z-scores. Remember the differences in formulas, and I hope this helped. So that's all we have today on z-score. I hope this helped, and if you have any further questions, please come into the tutoring center or ask your instructor.